It turns out that I could not teach object-oriented programming in just 2 videos of 15 minutes each, so here is the third one. We will continue working with our class credit card account, and so far let me remind you what the class was. We created an object called cat, the name of the object was Mr. Watson, and Mr. Watson made 2 transactions so that the 2 charges were added to the credit card. One was for $15.10 and another was for $15.20. We will now compile and run the program again. Just to remind ourselves how this was working. So in the beginning of the main function, we printed the message begin the beginning of main. Then, when the constructor was executed, the object was created. So the main function created one object of type credit card account that was cat. Its name was Mr. Watson. We added, and when this object was created, constructor was called. The constructor printed the message, constructor is executed. Then we added 2 charges, we printed the balance in the end, and as we exited the block of the code, the message, thank you for letting me be your destructor, was printed because destructor was loud. It printed this message. So I'm going to change this message because now we will create more objects of type cat. I will change the message to destructor for, and we will now print the name. So we will now try to recompile the program and see what happens. But before we go further, let us make another function that prints all the transactions, because you know, we have more data. We don't have to limit ourselves in just printing the balance on the account. We can print all the transactions. We will call that print statement. The method of the class will be void print statement, and the first message will be account owner is CNAME, the balance is balance, and now we will print all transactions. We will start by creating a pointer, a runner that starts from the address of the head of the transactions. Let me put this a little bit higher. While runner is not null pointer, we print runner content and one tab character. Runner becomes runner address of the next, and in the very end we print one symbol for the new line. Then we are, instead of just typing get balance, we will call the method that does more complicated action that prints the entire statement. Now we will compile this new program and we will execute. We forgot to put a print statement in the declaration. Void print statement. Now the program was compiled. Now we execute the program. And we can see how the statement is nicely printed. Owner is Mr. Watson, and the two transactions are from the newest to the oldest, $15.2 and $15.1. Then the destructor was called for Mr. Watson. Now we will create another object. So to test how several objects can be created, we can create cc account cat2. And instead of adding transactions for cat2, we will just copy everything in cat2 that was from cat1. So cat2 equals cat. So this way we have created object cat2 that will have the same transactions as cat, and then outside of this block of the code we can maybe change the name of the cat. So we did not want to add every single transaction again. We could just copy the old ones and try to see how that would work. So I'm just going to change the name of this second cat, cat2.cname, and let's call this second cat evil commander. And then we will type cat2 print statement. So now we will compile and execute this new code. So constructor is executed. This is the first constructor that is executed for cat2. Then another constructor is executed for cat. Then we print account owner is Mr. Watson, the balance is $30, and these are the transactions. And then Mr. Watson is destroyed when we exit the block of the code. So after this block of the code is finished, once the program reaches the end, this closed bracket, Mr. Watson is destroyed and the destructor is printed, destructor for Mr. Watson. Then the new one, the cat2, before the Mr. Watson was before the object cat was destroyed, evil commander is created, and we print the balance was $30, but we are confused by very wrong transactions that evil commander has made. So one transaction is for $0 and the other one is for something that is not even possible to pronounce, 4.6418e minus 310. Let me just point out that different compilers may give you errors because actually our code has a serious bug. And in order to see what is going on, we will now start drawing memory diagram. So I will now draw the memory diagram both for cat and cat2, and because I want to fit both diagrams in the same picture, the first step is make this cat a little bit smaller. And we will now consider what happens when the line cat2 equals cat is executed. It turns out that this line of the code is responsible for many bugs. So object of the class credit card account is created and we call it cat2. That object will also have the field cname, balance, and address of the head of the transactions. Now, what is going on behind the scene, if you can zoom in and see the RAM memory? First step is that CNAME gets copied and it becomes Mr. Watson. Then the field balance gets copied and it becomes $30.30. But here is where the bug occurs. When the address of the head of the transactions is copied, it doesn't actually copy the stack. So this address of the head of the transactions just points to the old stack of Mr. Watson. Then, when we exit the block of the code where cat was created, the memory is destroyed. So now cat2 points to memory that is destroyed. So technically, it's not that the RAM memory was burned, but it just doesn't contain cells that we are allowed to access. Those cells still exist in the RAM memory, but our program is not allowed to access them. So what most likely happened is some other process in the computer accessed the cell and rewrote the number 15.2 to 0, and then the pointer also points to who knows what cell in the RAM memory, and our code ended up with very big bug. Now what we will have to do is do some serious rewriting of our code and use something called copy assignment. And we want to copy the entire stack, not just copy the pointer. So what we will do first is create the function copy stack. So the function will actually return a stack pointer to the stack node, and its argument will be address of the old head we will now create address of the new head, and it will start being null pointer. If address of the old head is a not null pointer, then the new head will be allocated in a brand new piece of RAM memory. We will ask the computer, please give us sufficient memory for one stack node. Address of the new head in its field content will contain the same content as address of the old head. However, address of the new head in its content A next will contain copy of the stack, address of the old head A next. So this is a recursive function that copies the stack. Now we return address of the new head. Now we have created the method to copy the stack. We will now create copy assignment. How is this created? So it turns out that when we write the command cat2 equals cat, what happens behind the scene, computer replaces this command. It does search replace, because this is called assignment operator in computer science. In mathematics we call this equality sign, but in computer science this is assignment operator. So when we are working with basic types, integers, real numbers, strings, assignment operator is handled by C++. However, now when we are dealing with more complicated objects, this assignment operator is actually a method in the class, and that method has fixed name. It is always called operator equal of cat. So these two lines of code, cat2.operator equal of cat and cat2 equals cat, are absolutely the same lines of code. Just for the sake of elegance, C++ allows us to write cat2 equals cat. But what really happens behind the scene, a special method whose name is operator equal will be called. And if we do not make this method, computer will do its best guess. And the best guess was a disaster in this particular situation because the pointer just copied the address instead of copying the stack. So now we will overload the operator and our own version will be executed. So we will now create the operator, void operator equal. Its argument will be credit card account, and we will pass this argument by reference because we do not want to waste too much memories. The purpose of passing it by reference is to conserve the resources, so we do not want our argument of the function to occupy new memory. There is another reason, but I'm going to skip that now. So cc account operator equal cc account, and we will call it assign from. So we are assigning from another object. How do we perform this assignment? We will maybe type first something. Assignment, we will call it copy assignment is called. We first copy the name, cname equals assign from dot cname. Balance equals assign from dot balance. However, address of the head of the transactions will be copy of the stack. So we will now call copy stack assign from address of the head of transactions. So one small worry that you may have at the moment, you are maybe worried this code will not compile, you may not trust me enough, and your worry comes from the fact that I am accessing private attributes. I'm accessing balance of the object assign from, and C++ allows us to do that. Class, if I'm a programmer working with the class credit card account, when I'm writing the methods for that class, and methods for that class start with this word, cc account 4 dots, then I'm allowed to access private attributes of anyone in that class. So now let us try to compile this code and execute it. So it compiled. Now everything is much better. Evil commander now has its own stack, and when the object cat, whose name was Mr. Watson, was destroyed, the stack that belongs to evil commander remained the same. So we will now make another So we will now make another program in the next video where you are going to see that even current version of the program that we believe is perfect also has bugs. And so in the next video we will learn about copy constructor. So this was copy assignment, and there is also a need to have copy constructor because what we just did is not perfect code. So see you in the next video. Bye.